Imagine dropping a heavy book into a roaring fire. You just watch it burn down to a pile of gray ash.
Right, which is just a normal everyday physics kind of thing, entropy at work.
Exactly. But now, imagine those ashes suddenly swirling together, like reassembling into crisp paper, the cover binding itself tight, and the entire unburned book just leaps back out of the flames and into your hands.
Which would be terrifying to actually see.
Oh, completely. Because in our everyday experience, that is completely impossible. Time only moves forward, you know? Things fall apart. They don't spontaneously put themselves back together.
No, they definitely don't.
But according to this really groundbreaking new look at Albert Einstein's oldest equations, that exact backward flow of time is actually happening right now, just in a hidden mirror universe.
Yeah, I mean, it sounds like pure magic. But it is actually deeply rooted in mathematics.
It really is. So welcome to this deep dive. If you are a curious learner who loves a good aha moment and you're ready to unlearn everything sci-fi movies have taught you, you are in the exact right place today.
We are definitely taking a sledgehammer to the classic Hollywood version of the wormhole today.
Yes, we are. We're looking at a fascinating May 2026 article from Science Daily and The Conversation. It's called Einstein's Wormhole May Actually Reveal a Hidden Mirror of Time.
And the actual cutting-edge science behind it is pointing to a reality that is, frankly, infinitely more complex than just some cosmic shortcut from one galaxy to another.
Way harder to wrap your head around, too. Our mission today is to replace all that fiction with a reality that will completely change how you view your place in the cosmos. Okay, let's unpack this.
So to really understand the leap that modern physicists are making here, we have to start at the foundation. So the year's 1935.
Great, going back to the beginning.
Yeah, Albert Einstein and his colleague Einstein-Rosen published this highly theoretical paper. And the thing is, they were not trying to figure out how to travel the stars.
Not at all.
No, they were frustrated by a very specific mathematical headache, which was singularities.
Right, a singularity being a point in space, like the very center of a black hole, where gravity becomes so intense that matter is crushed into an infinitely tiny point.
Exactly.
And the laws of physics essentially just throw their hands in the air and break down entirely.
Precisely. And Einstein hated singularities. He absolutely hated the idea of infinities popping up in his elegant equations.
I mean, it messes up the math.
It does. So he and Rosen proposed a geometric workaround. They thought, what if, instead of a particle crushing down into an infinitely dense dead end, the math essentially just continued out the other side?
Like a bridge.
Right. They proposed a structural link, a mathematical bridge between two perfectly symmetrical copies of space-time. And this became known as the Einstein-Rosen bridge.
Okay, so it was basically just a neat mathematical trick to smooth out the equations for elementary particles.
Exactly.
And this is the crucial context that pop culture completely ignored, right? Like in 1935, they were modeling tiny particles. They were not proposing a transit system for starships.
No, definitely not.
But then you fast forward to the 1980s, and you have these brilliant minds like Carl Sagan writing science fiction and theoretical physicists like Kip Thorne wondering about it.
Yeah, asking, well, what if a bridge like that was large enough for a person?
Right. What if we actually tried to cross it? And I feel like that's when the term wormhole became this massive cultural obsession.
It really did. But, even the physicists doing those thought experiments in the 80s knew there was a fatal flaw in the design.
Which was?
Well, general relativity, the very framework that allows this bridge to exist on paper, explicitly forbids anything from traveling through it.
Because it's not a stable tunnel at all. I mean, I was trying to visualize the mechanics of this, and the old sliding grocery store door analogy, it doesn't really capture it, does it?
Not really, no.
It's more like, imagine a tunnel built entirely out of dry sand.
Right.
And the literal millisecond, a single grain of physical matter enters that tunnel. The added gravitational mass completely disrupts the delicate geometry.
Right, the gravity ruins the balance.
Exactly. The tunnel violently collapses and pinches off faster than the speed of light. So you wouldn't just be trapped inside. The tunnel would literally cease to exist before you even took a full step.
What's fascinating here is that to prop that sand tunnel open long enough to actually cross it, you would need to flood it with exotic matter.
Exotic matter. Which sounds made up.
It basically is. It's a purely hypothetical substance with negative energy density. Essentially, it's something that creates anti-gravity to violently push the walls of the tunnel apart while regular gravity tries to pull them shut.
And let me guess, we haven't found any of that.
We have zero observational evidence that macroscopic exotic matter exists anywhere. So an Einstein-Rosen bridge is fundamentally non-traversable.
It's just math.
Right, it is a geometric structure, not a portal.
Okay, so if we clear the board and accept that this bridge is not a physical tunnel connecting point A to point B in space, um, what exactly is it connecting?
That is the big question.
Like, if it's not a bridge across the galaxy, what is actually on the other side?
So this is where the physics shifts from spatial geometry to the flow of time itself.
Okay, my brain is ready.
Modern physicists, specifically building on the recent work of Saran Kumar and Joel Marto, have started looking at the Einstein-Rosen bridge through the lens of modern quantum mechanics.
Right.
And to understand their leap, you have to accept a very weird rule about our universe. At the microscopic fundamental level, the laws of physics are completely blind to the direction of time.
Wait, really? So if you zoom in close enough, the equations work perfectly whether the clock is ticking forward or backward.
They do. Think of a really simple physics equation, like calculating the trajectory of a billiard ball bouncing off a cushion.
Okay.
If you record that on video and play it in reverse, the ball's backward path still perfectly obeys Newton's laws of motion. There is perfect mathematical symmetry.
Oh, wow. I never thought about it like that.
Yeah. So Kumar and Marto suggest that if we take that fundamental time symmetry seriously, the Einstein-Rosen bridge isn't a tunnel connecting two distant places.
What is it then?
It actually represents two complementary components of a single quantum state. One component where time flows forward, and a mirrored component where time flows backward.
Okay, here's where it gets really interesting. Because for you and me, the listeners just going about our day, time is stubbornly a one-way street.
Oh, for sure.
We get older, not younger. But imagine reality itself is like a complex digital video file.
I like that analogy.
Right. For that file to be structurally sound and complete according to the fundamental coding of the universe, the data has to be rendering in forward and reverse simultaneously.
Exactly.
Even if our human monitors are only physically capable of displaying the forward playback, we only see the forward stuff.
Right. And the reason our monitors only display the forward playback comes down to one word, which is entropy.
The universe getting messier.
Basically, yeah. We are giant, complex, macroscopic beings made of trillions of interacting cells. On our large scale, things naturally degrade from order to disorder.
Right, the coffee gets cold.
Exactly. Your coffee gets cold, it doesn't spontaneously draw heat from the room and start boiling. Your cells age. The buildup of this disorder gives us a relentless, forward-pointing arrow of time.
So the reverse stuff is just hidden.
Yeah, we are completely blind to the time-reverse component of the universe because the overwhelming statistical force of entropy just washes it out completely.
But the microscopic world, like a single electron or a lone photon, it doesn't have a coffee cup to cool down. It doesn't experience complex entropy.
Exactly. When you strip away the macroscopic clutter and look at pure quantum evolution, especially in the presence of extreme gravity, like the crushing edge of a black hole, that quantum evolution must remain perfectly balanced and complete.
The math demands it.
Yes, you literally cannot mathematically describe the physical system without including both directions of time. So the Einstein-Rosen bridge is just the math demanding that a backward-flowing component exists to balance the cosmic ledger.
Wait. If time is flowing backward at the microscopic level near extreme gravity, doesn't that solve a massive, decades-old argument in physics?
Oh, you mean the black hole issue?
Yeah, like what happens to the information of a star that gets sucked into a black hole?
It absolutely solves it. It solves what is arguably the biggest headache in modern physics, which is Stephen Hawking's black hole information paradox.
Okay, break that down for us, because physicists have been losing sleep over this since, what, 1974?
Yep, 1974.
Yeah.
Let's look at the mechanics. Hawking proved that black holes aren't totally black. Because of quantum fluctuations at the very edge of the black hole, the event horizon, pairs of virtual particles are constantly popping into existence.
And normally they just instantly annihilate each other.
Usually, yes. But sometimes one particle gets sucked in and the other escapes.
And the one that escapes carries a tiny bit of energy away with it.
Yes. And over trillions of years, this Hawking radiation causes the black hole to slowly leak energy, shrink, and eventually evaporate into completely random thermal noise.
Which honestly sounds like a neat cosmic cleanup process until you realize it breaks the ultimate rule of quantum mechanics.
It completely breaks the rules.
Because if a black hole evaporates into random static, what happened to the specific, unique structural blueprint of the planets, the stars, the literal light that fell into it?
That's the paradox.
Right, because quantum mechanics says information, like the fundamental data of what makes a thing, can never be destroyed. It must always be preserved so the past can be reconstructed from the present.
But according to Hawking's original math,
Right.
once the black hole evaporates, that information is gone forever,
Yeah.
just sucked into a one-way void and erased.
And people just couldn't accept that.
No. Physicists have spent 50 years twisting themselves into knots, proposing wildly complex, exotic new particles just to find a place to hide that lost information.
Wow.
But the time mirror interpretation of the Einstein-Rosen bridge
Yeah.
offers a mechanism that is beautifully simple. The paradox only exists because we falsely assumed the event horizon of a black hole is governed by a single, forward-pointing arrow of time.
Wait, so the information isn't destroyed. It's essentially just taking a detour on a reverse time highway that we just can't see.
That's a great way to put it.
It's less like throwing a physical letter into a fire and hoping the ashes magically reassemble, and more like a palindrome.
A palindrome, interesting.
Yeah, like if you read the word race car forward, it enters the black hole and disappears from our timeline. But the universe doesn't throw the letters away, it just starts reading race car backward from the other end.
Oh, that's perfect.
The letters, the core information, are exactly the same, perfectly preserved, just flowing in the opposite temporal direction.
If we connect this to the bigger picture, that palindrome analogy really highlights the true elegance of this theory. Completeness and causality are perfectly preserved.
So the math finally balances out.
Yes. At the microscopic level, the quantum information of that star reaches the event horizon, which is the point of no return for our forward-flowing time. But it doesn't vanish into a singularity.
It just slips.
The Einstein-Rosen bridge allows that exact quantum state to pass into the mirrored temporal direction. It simply leaves our timeline and continues evolving perfectly intact along the reverse timeline.
That is mind-blowing.
We didn't need to invent new physics to save the information. We just needed to accept that time operates in both directions to keep the math whole.
I mean, I love it, but I'm struggling to fully buy this. Like, math on a chalkboard is one thing, and solving paradoxes is great.
Sure.
But if literally half of the fundamental quantum state of the universe is flowing backward, shouldn't we see a footprint of that in our own night sky? Why don't our telescopes see backward-moving light or some kind of physical proof?
Well, actually, cosmologists might have been staring at the physical proof for 2 decades without realizing what it was.
Wait, really?
Yes. But to see it, you don't look for backward-moving light. You look at the cosmic microwave background, or the CMB.
Okay, this is the literal afterglow of the Big Bang. The oldest light in the universe, dating back to when the cosmos first cooled down enough, about 380,000 years after the start, for light to finally travel freely.
Exactly. It's like the baby picture of our universe.
Right. And if you were to tune an old analog television between stations, a tiny fraction of that static on the screen is actually the microwaves from this exact afterglow hitting the antenna.
I always love that fact. Now, standard cosmological models, which assume the universe expanded uniformly under a single forward arrow of time, they predict that this afterglow should be completely symmetrical.
Just a perfectly even spread of heat.
Right, it should be perfectly balanced in all directions. But it isn't.
Oh, right, there is a persistent anomaly there. Cosmologists call it a parity violation.
Yes, they do.
When you look at the static of the universe, it has a slight-handedness. It prefers one spatial orientation over its exact mirror image. It's as if you looked at a massive forest and realized slightly more trees were leaning to the left than the right for no discernible reason.
That's a great visual. And under standard forward time-only physics, the mathematical probability of this specific lopsided tilt existing across the entire universe is astronomically low.
It's an anomaly that just shouldn't be there.
Exactly. But let's bring the mirror universe into the equation. If a twin component of our universe is actively evolving backward in time, it isn't just a separate ghost world.
It's connected.
Very connected. It is fundamentally entangled with our universe at the quantum level, tracing all the way back to the incredibly dense, extreme gravity of the universe's origin.
Oh, wow. And because they share that fundamental quantum entanglement, the backward-flowing twin is subtly tugging on the fabric of our spacetime.
Yes. That entanglement at the moment of creation would exert a physical geometric pull on our expanding reality. It would leave a lopsided physical tilt in the residual heat of the CMB.
So the math actually predicts the anomaly.
It does. When researchers like Kumar and Marto introduced this time-reverse symmetry into the mathematical models of the early universe, that bizarre, unexplained tilt in the afterglow suddenly makes perfect mechanical sense.
So it's basically the footprint.
Yes, it is exactly the kind of footprint a hidden, backward-flowing mirror universe would leave on our sky.
Wait, if the afterglow of the Big Bang contains the gravitational footprint of mirrored time, that forces us to ask a massive, frankly terrifying question about the Big Bang itself.
Oh, absolutely.
Because if time flows backward across this bridge at the point of extreme gravity, then all the matter in the universe didn't just spring from a microscopic dot of nothingness, did it?
It absolutely did not. And this is where the theory shifts from solving black hole paradoxes to completely redefining our place in the cosmic order.
Okay, I'm ready.
If this framework holds true, the Big Bang was almost certainly not the absolute beginning of time. Instead, it was a bounce.
A bounce. Walk me through the mechanics of a bounce.
Imagine a parent universe, incredibly vast and ancient, existing before ours. Within that parent universe, a massive, closed region of space-time begins to collapse inward under its own crushing gravity.
So it's forming a gargantuan black hole.
Exactly. But as all that matter crushes down, it doesn't reach an infinite singularity. It hits a physical quantum limit, often called a Planck star, where the density is so extreme that the fundamental laws of time and gravity essentially rebound.
Like it hits a floor.
Right. The collapse violently stops, reverses direction, and begins expanding outward in a new time direction.
Are you saying our entire infinitely expanding universe is literally the interior of a black hole that exists in a different, older universe?
That is precisely the mechanism this interpretation suggests. Our universe is the expanding interior of a black hole that formed in a parent cosmos.
That is heavy.
The Big Bang wasn't a sudden explosion from nothing. It was a transition point. The collapse of the parent universe's matter created the intense extreme gravity required to form an Einstein-Rosen bridge.
But it wasn't a bridge through space.
No, it was a bridge through time.
I just need a second to process the sheer magnitude of that.
That's a lot to take in.
The Einstein-Rosen bridge is the temporal umbilical cord connecting us to a prior universe. It is the hinge between a universe that died by collapsing and the one we are currently living in, which was born from the rebound.
This raises an important question for any physicist looking at this model, though. How do we prove it isn't just beautiful math? How do we test a bounce?
Right, because we can't exactly look outside our universe.
No, we can't. But if our universe was born from a pre-existing contracting phase, if there was a universe before ours, then the bounce itself might have been a messy process.
Messy how?
It stands to reason that some incredibly dense relics from that parent universe could have survived the transition and spilled over into our expanding timeline.
Surviving relics, what could possibly survive the crushing bottleneck of a universal collapse and rebound?
The most likely candidates are primordial black holes. Much smaller black holes that formed in the parent universe were dense enough to ride out the extreme gravity of the bounce and are now scattered invisibly throughout our current universe.
Wow, just hiding in plain sight.
Exactly. They wouldn't emit light, so our optical telescopes could never see them, but they would still possess immense mass, meaning they would exert a massive gravitational pull on the galaxies around them.
Wait a minute. Invisible mass exerting heavy gravitational pull on everything we can see. You are talking about the exact definition of dark matter.
Which is one of the greatest unresolved mysteries in all of astronomy.
Because we know dark matter makes up roughly 85% of all the matter in the universe, right? Galaxies would fly apart without its gravity holding them together.
Yes, but we have no idea what particle actually makes it up.
And this solves it.
This time mirror theory offers a staggering, elegant mechanism. Some, or perhaps all, of the unseen mass we call dark matter is simply the surviving ancient fossil record of the cosmos that existed before our Big Bang.
That reframes our entire understanding of reality. The Big Bang isn't page 1 of the book, it's the start of the second chapter.
Beautifully said.
And dark matter isn't some mysterious new particle we have to discover in a collider. It's just the leftover shrapnel from chapter 1.
It changes the narrative entirely. And what is most profound about this mechanism is that it doesn't discard a century of hard-won physics.
It doesn't break the old rules?
No, it doesn't overthrow Einstein's relativity or rewrite the rules of quantum mechanics. It actually fulfills them. It harmonizes gravity and quantum behavior by simply removing the artificial human boundary we placed on time.
The idea that it only moves forward.
Right. It provides a geometrically complete picture where space-time breathes in a perfect continuous cycle of collapses and bounces, balancing opposite directions of time to keep reality stable.
You know, we started this deep dive by killing the sci-fi dream of wormholes. No starships flying through glowing tunnels, no instant shortcuts to the Andromeda Galaxy.
Sorry to burst the bubble.
Yeah, and if you're a sci-fi fan, I know that might have felt like a massive letdown at first, but what we've discovered in its place is so much more spectacular.
I completely agree.
The universe isn't just a straight, relentless line ticking down from birth to a cold, dark death. It is a perfectly balanced mirror. It is a system that demands both forward and backward time to exist in harmony.
The next great revolution in our understanding of the universe won't be about building a hyperdrive. It will be about proving that deep down, at the microscopic foundations of reality, the universe is infinitely more resilient, symmetric, and deeply connected than our everyday experience allows us to see.
And as we wrap up this journey, I want to leave you with one final lingering thought to turn over in your mind today. We've established that the foundational building blocks of the universe, the raw quantum states that make up absolutely everything, require time to flow both forward and backward to be mathematically complete.
Yes, they do.
But think about what you are made of. You are constructed from trillions of those exact same quantum particles.
That's a profound thought.
So if the bedrock of reality requires a mirror of time to function, does some microscopic fundamental part of your own quantum blueprint exist in both the past and the future right now? Is a tiny, unseen fraction of you quietly flowing backward down the mirror of time, even as you sit here listening to this?
It is a deeply haunting and fascinating mechanism to consider. The universe, and by extension ourselves, might be engaged in a temporal dance that we are only just beginning to measure.
It truly is. Thank you for joining us today, for letting us stretch your imagination, and for exploring the hidden mechanics of time with us. Keep questioning what you think you know, keep looking up at that lopsided static in the night sky, and we'll catch you on the next deep dive.